Okay. Question already.
Yes. What do you mean by trends?
Oh, like
Trends, like the periodic trends.
Oh.
Yes. So today is a review. This will all be online on the website. So you can go after school, you can check the website, and it'll be there. It'll be up for you. Let's try to get this done quickly. So Curies, the first thing you should know is that you could look at your quizzes for Marie Curie, Pierre Curie, that whole booklet that we did. You can look at your quizzes there. And those quizzes with the multiple choice answers and so forth, those are going to be the same basic kinds of questions that I'll ask on the test. So look at those quizzes, that quiz I should say, just one quiz, and I think it's 3.1. Look at that quiz, and that's your study guide for what's going to be covered on the test. So things like Marie and Pierre, how'd they meet? They met over tea. They met because there's this guy who introduced them. Marie wanted to work in a different lab, and she knew this other guy, Pierre, and they met over tea, and they were friendly. They fit in love. Oui. They fit in love. And what else? They were lab partners in the sense that they did not. Pierre normally would feel as if a love interest would distract him from his work, and he was heartbroken earlier on in his life, just like Marie was. But in Marie, he found a partner who could really help him and was a collaborator, not a distraction. And Marie felt the same way. It's just this amazing match of people. So, what else happened? We have this definition of what a normal accident is. We talked about that a little bit in our discussions. A normal accident meaning that little tiny events that seem like they're not really going to be adding up to much along the way, they end up having this huge effect.
Wait, are we supposed to be
Yeah, you can write down notes if you like. I'm recording it also, so you can just look at the recording. Or you can just listen to.
Wait, are you going to write stuff on the board?
Yes, I'm just talking to you right now about what Marie Curie and Pierre Curie, the information that we covered.
I just don't know what to listen.
That's okay.
Radium and polonium.
Yes, they discovered two elements, radium and polonium, and for that they got the Nobel Prize. They purified pitch blende.
Do we have to know those two elements?
Radium and polonium, yes. Poland, Marie named polonium after her native country, Poland, and radium and polonium.
And how do you spell that?
P-O, all right up on the board. Radium and polonium.
It's like polo and
Polonium. They discovered those two elements. Marie won the Nobel Prize again, but it was amid controversy. The controversy was due to her affair with Paul Langevin, or Langevin. I can't say it. Sorry. This guy. He was married at the time, that's why it was scandalous. At that point, Pierre had already died. His head was crushed by a carriage carrying military supplies.
Who's building military supplies?
Yes,
know how.
you do.
You need to know about how like it was little
the details.
You don't need to know the details, I just said
it was like little things that created.
That's called a normal accident. Normal accident. Right there. On the board too, normal accident, what that is, it's a series of small failures that don't seem like they're much at the time, but when they start adding up, they can create a huge tragedy.
Do you have to know about their like their injuries or stuff like?
No. No. Yes, that was a question on there, but you don't need to remember that. That's a little bit too much.
Yeah, like the specific.
Yeah, don't worry about that. That's fine. Okay, so that's Marie Curie, and Pierre Curie's information that I think you should know for this test. Any questions? Okay, good. Electron configuration. All you need is this thing right here, and you'll be given this. Hold it up for the camera. The Aufbau chart. The Aufbau chart. This thing right here. You just count from left to right the number of electrons you have in the atom, and this tells you which shells they'll be in. So if you've got two boxes lined up in the first shell, well, guess what? You put 2 for that first shell. Same thing for the second shell, third shell, and so forth. Okay? We've done this a lot. If you've got a charged atom, though, if you've got, like, let's say calcium, and it's -2, what does that mean in terms of electrons? How many electrons do we have if it's calcium -2?
That's 2 more.
No, it's not 18.
22.
It's 22. Normally, a regular calcium would have 20 electrons, right? And we put that in the alpha chart, and we find out that it's 2-8-8-2. But in this case, for calcium with a -2 charge, that -2 means that there's 2 extra electrons.
That's
How do you know
Why would
that
they say
they're
minus
not
two?
taking
It's a
away?
-2 charge.
Oh,
It
okay.
has nothing to do with the number of electrons. Right here we've got 22 electrons, so that translates into 2-8-8-4.
Wait, no.
No, 2-8.
2, so it's going to be this.
Yeah.
Ah, it's a little bit trickier. Okay, that's right.
How do you know that they're not taking away protons?
Because it's still calcium. If they change the number of protons, it'd be a different element.
How do you
What
know
if
the-
calcium is +2 charged? How many electrons?
18.
Oh, minus
18 electrons. So now the electron configuration would be 2-8-8. That's it.
That's weird.
Questions about this? Okay, should be straightforward. We can calculate, let's use the same example right now and calculate effective nuclear charge, because that's a tough one. Everything okay, Cassandra? Okay, good. So let's do that. We've got right here, I want to calculate for this atom right here, the non-charged atom, the neutral atom. I want to calculate the effective nuclear charge for the valence electrons. So I can calculate the effective nuclear charge for any of these electrons right here, but I'm going to do it for the valence electrons, so let's do that. So how do I do that? Lawrence?
So first you have to add up the shells before the valence one. So that's 2 plus 8 plus 8, so that's 18.
So that's 18 right there.
And then you subtract 18 from 20 because you have to
Right,
because it's
right. So the Z formula is protons minus the inner electrons. So this is going to be 20 minus 18. Right, 20 is the number of protons in calcium. That's always going to be 20 for calcium. 18 can change depending on which shell you're considering here. Right here we're considering our last shell right here, the valence electrons. So all of these are going to be inside those valence electrons. So they're going to be blocking those valence electrons from seeing all of the positive charge in the middle of the atom. So you're going to have to subtract that 18 right there. So the final answer then is 2.
Sorry, Mr. Smith.
Yeah.
Where do you get the two numbers from? Sorry, I wasn't.
20 and 18. 20 is the number of protons in calcium.
How do you know that?
You just look it up. It's
Oh,
calcium.
yeah.
It has to be 20. There's no other element that has 20 protons.
Wait, are you gonna quiz us on the first 20?
Yes.
What about 18?
What about 18? The number 18? Number 18 came from all of the inside electrons.
Oh, so you take everything except the last.
That's right. You got it. Yes.
Wait, it's not the valence electron?
Let's do that right now. Okay, so let's just walk through that. So this right here is for the valence electron, the effective nuclear charge for the valence electron. But let's consider a different shell. Let's consider the electrons in the second shell. Oh man, we could have done the third, but let's do the second. Let's do the second right here. Let's use red for this. We want to figure out the effective nuclear charge for these. Oh, I did the third. Whoops. Let's do the second. Right there.
Wait, is it basically just the shell that's blocking it and you don't count the shell that is on? Or
That's right.
before?
So for this one right here, we've got,
10.
what's the first number we're gonna
20.
We're gonna have 20, yeah, 20 because there's 20 protons in calcium, minus 2, because there's only 2 electrons blocking this shell right here. There's only 2 of them that are blocking this shell.
18.
So it's overall going to be 18.
Oh, so you'll ask us the question like, what is the nuclear charge in the second shell? And
Yeah.
For calcium, and you'll.
Yes.
Really?
That means a lot.
No, I love that. I love when he comes up and asks a question. That's great.
I'm engaged.
I like it. Okay, so this works for this atom right here, this kind of formula. Can you do the same thing for this? Let's try this. Let's figure out what the effective nuclear charge is now for the this valence electron over here. See if it's any different.
Wait, the protons stay the same.
Yeah, they do.
22 minus
22 minus?
No, it's
20,
the protons.
It's
stay
just 20 minus the number of shielded electrons now.
which is
Zero.
3.
That's 20 right there. So 20 minus 20, so
0.
0.
Wait, is that possible?
Yeah.
Oh.
It's crazy.
0 nuclear charge.
So that rarely happens. That means that electron, right, those electrons over there in the last shell, they're like totally not going to be connected.
Why does that not? Why is that?
So they're not
Why
So
is
this
that
is
not,
like a fictional atom, really,
Why does it not happen a lot?
because there's no charge right here attracting them to the nucleus.
What?
So they're just like floating there.
So this is a fictional atom right here. I just made this example up.
Oh.
It's totally fictional.
I
Okay.
don't get how would you why is it 0?
It's 0 because there are how many electrons blocking it? We've got 2,
20.
8.
Yeah.
So 20 is the number of protons.
It's 22.
Minus 20,
It's always the number of
0.
protons.
Yeah.
Oh, I do the number of like electrons, which is normally should be the number of protons if it's not like a charge.
Yes, you're right. But it is charged here. So we have to consider the number of protons here. So if you consider the number of protons, we've got 20 protons minus 20 shielding electrons. Those are inner electrons. So that gets you 0. You had a question?
You're gonna ask
This is
that,
0.
definition of Zeph.
Okay.
Why we use that.
No, but you should know that.
It's
Okay.
mostly just follow.
Questions about effective nuclear charge. I can ask you any question about any one of these shells right here, Adon. I can ask you any question about any one of these shells. I can say, what's the effective nuclear charge for, let's say, this one right here,
First shell.
Where's the first
20 minus 0.
which is
20.
good. Boom.
Wait. All right. Let's do a different one.
Let's do a different one.
It's not good.
Yeah, you should go like in the screen of the video.
We gotta see it. We gotta see it done.
Yeah, go.
No, it's okay. All right. So here it is. We can choose any other element. Let's choose.
Oh, you're
Let's
gonna give
choose
us
oxygen.
hydrogen tomorrow. and
Let's
we
do
get rid of
oxygen.
you. You're gonna give us hydrogen.
No. Oxygen. Oxygen minus. Let's do a -2 oxygen.
Alright. Wait.
-2 oxygen.
That's 18.
Let's try it. -2 oxygen. Right? How many electrons do we have for -2 oxygen?
60.
We
Why?
have
This would be 14, 18. What element is it?
-2 oxygen. How many do we have?
Like, can I just
Total.
put it on a table?
Total number of electrons.
Isn't it
No.
like 7?
10.
8.
Oxygen is 10.
This is starting to worry me.
Oxygen minus 2 is 10.
That's right.
Yes, done.
Oh, I was saying 8 for like what the normal.
Yeah.
So the electron configuration is going to be 2-8. Yes. Okay. So Adon, what
Yeah.
is the effective nuclear charge of this electron right here?
8.
No,
What?
what is that?
Oh, the Zeph?
Yeah.
It wouldn't it? Oh, wait. Oh, so it'd be 8, 6.
8 minus
Yeah. 8 minus 2.
2, 6. Yeah.
Maybe.
Good.
I didn't say no.
You said no.
That's actually the same, Adon. It's actually the same as if it wasn't charged. If it wasn't charged, it'd still be 6.
Wait, are you saying? Oh wait, never mind. I was just gonna say something.
It's okay.
Oh.
All right. That's the. Let's talk about metals. There's a little break. Metals are pretty easy. What are some properties of metals? Well, let me think. One of them is malleable. It's conduct electricity.
What about metals?
Okay, let's go through some of these things. We can make it sharp.